October 31st, 1996. TAM Flight 402, a Fokker 100 regional jet with 95 people on board, is taking off from Sao Paulo, Brazil, bound for Rio de Janeiro, Brazil. During the takeoff roll, warning lights illuminate, letting the crew know that the auto-throttle is not functioning. The captain calmly, manually takes control of the throttle and continues with the takeoff. 50 feet off the ground, the number 2 engine throttle moves to idle and the plane begins banking to the right. The first officer fights with the throttles and gets the number 2 engine back to full power. The number 2 engine keeps rolling back to idle, but the first officer keeps fighting it. However, the captain is unable to regain control of the plane as it continues banking right and crashes into a crowded neighborhood, killing all on board as well as 4 people on the ground. Why did the throttle keep rolling back to idle? Was this the reason the plane crashed? Find out on this episode of Black Box Down. Hello, everyone. Welcome to Black Box Down. It's Gus and Chris. Hello, Chris.
Hello.
We have another incident that occurred on Halloween. We've had a few recently that occurred on October 31st. We're not picking these on purpose to be around Halloween. It's just a coincidence. Dennis pointed out that this is our third here recently that's been on October 31st.
You know, that makes it spookier.
Ooh, spooky.
If we're not doing it intentionally.
I don't, for the record, I don't believe in, in coincidences. I don't think it's a cursed day to fly or anything like that. It's just happens to be a weird coincidence.
There's something that could be haunting us specifically.
Oh, gotcha. Before we get started, as always, I want to remind you to give us a follow on social media at Black Box Down Pod on Facebook, Instagram, Twitter. You can see pictures of things that we talk about, and you can see pictures of our merch. We just had some new merch come out here very recently featuring the autopilot little guy from our aviation explanation videos. I think it's great. We got a shirt, mug, decal. I think they're all great. I think the shirt's so soft. It feels great. It's embroidered. It's like really high quality. Love it.
Yeah, and the even if you haven't seen the autopilot guy, the mug is really cute. It's like a little autopilot thing. It says running on autopilot. So it's like you drink it in the morning with your when you're
makes sense.
Like I am right now.
I finished my coffee already. I finished before I sat down on my desk. But yeah, great mug. Anyway, that's neither here nor there. Right now we're talking about TAM Flight 402. There was a little bit of confusion I had that I want to mention real fast at the top regarding this airline. You know, TAM, it's TAM. This airline eventually became LATAM, LATAM, which I think we've talked about in another episode before. And it actually has like a really long name because I think that, again, this was confusing. There were different airlines operated by this TAM group. This one specifically is TAM Transportes Aéreos Regionais Flight 402. They also had another TAM called Taxi Aero Maria. They were two different entities, but they both belonged to the TAM group. So this one, I just want to get this out of the way. This was Transportes Aéreos Regionais, which eventually became part of LATAM later.
Okay.
Or I guess rebranded or whatever. They're LATAM. They became LATAM. Anyway, it was just a little confusing. And, normally I'd like to clear that stuff up at the top. So if I say TAM, that's what I'm talking about. So this was a passenger flight from Sao Paulo. It was actually going to, I don't know how to say it, Recife, Brazil, but it was stopping at Rio de Janeiro. So this specific flight was going from Sao Paulo to Rio and then was going to continue on back October 31st, 1996. The flight was crewed by Captain Jose Antonio Moreno, who was 35 years old with 6,433 hours of flight time, and First Officer Ricardo Luis Gomez, who was 27 years old with 3,000 flight hours. The aircraft used was a Fokker 100 with 8,171 hours, and there were 4 flight attendants and 89 passengers on board. I think this might be the first incident we've covered in the Fokker 100 plane.
I was going to say, that name, I don't think we've talked about.
It wasn't a terribly popular plane. There were only 283 of them built between 1986 and 1997. And it looks kind of like... it's a regional jet, right? So it's got, in this particular plane, has the 2 engines at the back of the fuselage, kind of like an MD-80. They're not, the engines are not under the wings. And it's a little smaller, kind of, it's a regional jet, kind of like a CRJ or an Embraer. Anyway, the engines, back of the plane, not under the wings. Just, we're talking about the engines at the intro, so just trying to get you to picture what it looks like in your head.
Okay.
Fokker was a Dutch aircraft manufacturer. I was familiar with them because of the work that they had done years ago, back in World War I. Like they used to be around for a long time. They went defunct actually in 1996, but they made a lot of like the plane that the Red Baron from World War I.
That's what I was just looking at.
Yeah, the plane that the Red Baron flew was a Fokker. Like these were very iconic planes back then. So it was an aircraft company that had a long history and had been around for a long time. Eventually, they went bankrupt and they don't really exist anymore. But the Fokker 100 was kind of like their last attempt at, one of their last attempts at trying to gain relevance.
Or regain.
Regain relevance. Gain modern relevance. People aren't strapping Gatling guns to the nose of their plane and flying around anymore. You don't make a lot of money that way anymore, unless you're, Boeing or Northrop Grumman. Anyway, so Flight 402 received clearance to depart Sao Paulo at 8:26 a.m. And during the initial acceleration on the runway, the captain announced the actuation of the takeoff go-around switch, and the first officer confirmed everything was in a normal condition. So, that means they're going to go max power, max throttle, and, they're attempting to take off. 4 seconds after that initial acceleration, there was a beep sound in the cockpit, and the captain said, "Hey, this is what? It's out, see?" And the first officer replied with manual. What happened was one of the two auto-throttle channels had been disconnected. But, according to the report, something like this doesn't require correction. This isn't a big deal. They just have to manually control the throttle at this point.
And it's just max, right?
Yeah.
So they just like
all the way. Yeah. The captain then said, "Auto-throttle is out." At 8:26 and 10 seconds, two beeps sounded, and the captain repeated again that the auto-throttle was out. The first officer then said, "Thrust check," which is like confirming that takeoff thrust has been adjusted and checked, They look, yeah, maximum thrust. So, auto-throttle's out, thrust check, yep, it's good. So they continue. And they rotated at 8:26 and 34 seconds at a speed of 131 knots, which is about 151 miles an hour or 243 kilometers an hour. So shortly after takeoff, there were some knocks recorded on the cockpit voice recorder. And at 8:26 and 36 seconds, the EPR for engine number 2 started dropping from 1.69 to 1.34. And we mentioned before, EPR is just like a thrust rating. So the fact that it's going down from 1.69 to 1.34 indicates that engine 2 is starting to give less thrust.
Okay.
The first officer let out an exclamation, and over the next few seconds, the plane started rolling to the right at about 3 degrees per second, reaching 11.2 degrees. The crew is able to counter this by inputting left rudder and using aileron movements. At 8:26 and 40 seconds, the first officer said, "It's locked." The report notes that this is likely referring to the throttle lever for engine number 2, which was now at idle. So engine 1 is still at max power because they're taking off. The lever for engine 2 has gone all the way down to idle, and the first officer has said, "It's locked."
And there's just the two engines.
Correct.
Right?
It's a two-engine
They don't
plane.
have a third.
Yeah, no third, no fourth, just two. Engine 1 went to 1.328 EPR, and engine 2 went to 1.133. So they're both rolling down a little bit. And at 8:36 and 44 seconds, one of the pilots said, "Turn it off up there, auto-throttle, pull here." And the EPR for engine 2 started to rise again as the lever was brought forward. But then it quickly reduced to idle again. So presumably they're trying to disable the auto-throttle. They think that the auto-throttle is maybe kicking in and messing with the throttle. So they're trying to disable it and bring the engine back up. At this time, the plane also pitched 1.55 degrees nose down. It doesn't sound like much, but remember, they just took off. They're not very high off the ground. A few seconds later, the first officer indicates that the auto-throttle system was already off.
Oh.
You remember they had even said it before, off, off. And, the throttle for 2 is acting up. The captain's saying, or someone's saying, "Turn it off, auto-throttle," and they're like, "It's already off."
Oh, no. Oh, no.
Then both throttle levers were pushed forward again, and both engines exceeded 1.724 EPR. So they're getting thrust again out of both engines. The captain repeated, "Turn off up there, here also," referring to the auto-throttle control switch. The speed started to deteriorate at 2 knots per second, and the stick shaker sounded at 8:26 and 55 seconds. 2 seconds later, the aircraft suddenly banked 39 degrees to the right, and the ground proximity warning system started sounding.
Is that because one of the engines isn't powering at all, and it doesn't have a balance, thrust?
Yeah, they call that asymmetrical thrust.
Yes, that's what I was searching for. It's like,
So presumably that's what it sounds like, right? Engine number 2, which is the engine on the right, it keeps rolling back to idle. They're fighting to get it going, and the plane's banking and going to the right, which you would expect when you're only getting thrust from the left side.
Yeah.
So yeah, you're right. You're on the right track. That's entirely what it sounds like. In planes like this, the asymmetric thrust is not as it's still there, but it's not as pronounced since the engines aren't out under the wings. The engines are close to each other at the back of the fuselage.
Yeah.
So it's not as severe.
As bad. Yeah.
Right. But it does still exist. The flight then crashed at 8:27 in 1 second, hitting several houses and buildings, killing everyone on board and 4 people on the ground. There's actually, like I said, this was 8:26 in the morning. There's actually a crazy photo from this incident. Let me make a note. I'll post this on our social media. There's a crazy photo of the landing gear in someone's bed.
Oh my God.
Right. It's like, luckily they had gotten up, they had started their day, but like the landing gear was in their bed where presumably they were asleep just a little bit before this.
Oh, that's terrifying. Oh my God. Can you wait here? I want to see that photo. Oh. Wow.
Yeah, so I mean, if you think about like even how a landing gear gets into a home to land on a bed, I mean, it destroyed a wall. Like everything in the room is destroyed.
Yeah.
And it landed on their bed. And I mean, it destroyed the bed too. I mean, the landing gear is really heavy.
Yeah, and even for a smaller plane, right? A regional plane, those are big wheels.
Well, I mean these are regional planes, but they're still, I mean, a ton of people are on them. They're still, really big planes.
That landing gear, you might call that the leg. What is that?
Like the strut that's holding it?
Yeah. I mean, that's like twice the size of that dude standing next to it.
Yeah, there is a man standing by the wheel. The wheel itself is like half the size of the guy. And yeah, the strut is like bigger than he is. It's absolutely crazy the amount of damage that it did. Okay, so this is a good time to give you a warning, Chris.
Uh-oh.
This report was very technical and very thorough and it was more technical than we were used to. It's going to deal with a lot of electronics. So I did my best to try to learn everything that's going on. I'm going to do my best to try to convey it. But please, if you have questions, let's dive into it and dig into it and try to unravel this together. Also, this was a weird report. Obviously, this incident happened in Brazil. It was not an American-made plane, so the NTSB was not involved at all. So the report was in Portuguese, had to get translated, and they just do their reports a little differently there. Like, for example, the report didn't list any altitudes where things happened. But I think they eventually figured out that everything started going wrong about 50 feet off of the ground. So
50, yeah,
just trying to set it up now that this might come across a little different than a typical episode.
I'm ready.
So, like I said, NTSB was not involved. The investigation was carried out by the Aeronautical Accidents Investigation and Prevention Center, or SANIPA, and they were told by witnesses that the right engine reverser had opened during the flight. And we've talked about these before. The reversers, the thrust reverser.
For landing.
Right. There's a bunch of different ways that these things work, but essentially, in this case, it's like a little bucket that opens that redirects the thrust so that instead of propelling the plane forward, it makes the thrust kind of go in the opposite direction. Yeah, forward, so that the plane slows down.
Which would explain, that's like the asymmetrical thrust, like on steroids.
Yes. It would be like if you in your car had separate brakes for the left and the right tires, and you were accelerating on your left tires and slamming on the brakes on your right tires.
Oh, man. I mean, that would make you do a circle, right?
Right, yeah. Like you'd go to the left, which is, what happened to this plane, except they have a third dimension. They also have, verticality to worry about. And that's why, they ended up going down. The things slow down on the right side. You don't have as much lift. You dip down and ended up crashing. So, of course, we've said before, eyewitnesses, very unreliable. Mm-hmm. We've covered this extensively. People say they see explosions on planes or they see stuff on fire, and then the investigation's like, yeah, that actually didn't happen. So, of course, the investigators get told that eyewitnesses on the ground saw that right engine reverser open, so they're going to look into that. So, they look at the hydraulic system for the reversers, and they have two vital components. One of these components is the thrust reverser selector valve, and they tested and inspected it, and they concluded there was no operational anomaly in this part that contributed to the opening of the reverser. The other component is the thrust reverser actuator, but the actuators were also found to be fully operational. So a technician from Fokker prepared a hypothesis that says that the high resistance of one of the switches for an actuator might have reduced the performance of the open-close limit relay, sending spurious signals to the selector valve's open-close solenoids. So basically saying that there was a high amount of electrical resistance on the switch, and maybe it's not quite short-circuiting, but maybe it was causing the thrust reverser to get faulty signals.
Oh, like
it was kind of being overloaded maybe and just kind of like wasn't, getting a full proper signal.
And then because it was like it didn't know what the signal was and it was saying open, go.
Yeah, or like a weak open signal or then like a weak closed signal like that, where it's like it's not the same thing, but maybe like a flickering light where it's like, yeah, it's on, but it's not all the way on. It's kind of on, kind of off.
But it shouldn't have been on in the first place, right?
Correct. Yeah. So and again, this is a hypothesis. They don't know. Like they're looking at the parts and they're like, the parts are fine. What else could it be? So there's an engineer, from Fokker, from the aircraft manufacturer, who's like trying to figure out, well, is it possible for this to happen? And this hypothesis also showed that a fault in the energized position of the sectioned lock relay engine 2. So this fault would not cause the reverser to open, but it would inhibit a warning to be sent to the cockpit if the opening did occur. So they're saying like this other fault doesn't necessarily make the reverser open, but if this fault happened, there would be no warning in the cockpit saying that this was happening. So it's like now like we talk about like the Swiss cheese model and how lots of things need to go wrong for a crash to happen. It's like, well, theoretically, this could have caused the reverser to maybe not be all the way closed, maybe be opening a little bit. And also it would disable the warning in the cockpit that would let the pilots know this was happening.
That is like one thing that does a lot of problems.
Right, yeah. So the switches for the lock actuators were tested, and one of them showed an extremely high resistance of 357 ohms, and the normal resistance value would not exceed 0.7 ohms.
Oh.
And the other actuator tested had a maximum resistance of 0.5 ohms. So this is kind of falling along that hypothesis, like, oh, there was a lot of resistance on this side, and this would account for the crew not being notified that the thrust reverser had deployed.
Yeah.
With HelloFresh, you get farm-fresh, pre-portioned ingredients and seasonal recipes delivered right to your doorstep. Skip trips to the grocery store. Count on HelloFresh to make home cooking easy, fun, and affordable. That's why it's America's #1 meal kit. You can savor every last second of summer with HelloFresh. HelloFresh delivers fresh, quality produce from farm to your door in less than a week, allowing you to enjoy the delicious flavors of the season right from home. Skip the trip to the grocery store. Spend more time soaking up the last of the summer sun. HelloFresh Market is a one-stop shop for all your mealtime needs with a curated selection of quick breakfast, lunch, snacks, desserts, and more. Plus, on top of that, HelloFresh's quick and easy recipes, 20-minute meals, and low prep, low cleanup options provide an even faster route to putting food on the table around your packed schedule. I'm a big fan of HelloFresh. It's not only is it a time saver, everything's really delicious. I feel like it's a quick project that's super easy to do. It takes me about 30 minutes. Lay out all of my ingredients, put it all together. Then at the end, you get to eat it, and it's so good. You feel really, really accomplished. So go to HelloFresh.com/BlackBoxDown16. Use code BlackBoxDown16 for 16 free meals across 7 boxes and 3 free gifts. That's BlackBoxDown and the number 1 and the number 6. So HelloFresh.com/BlackBoxDown16, code BlackBoxDown16. Make sure you use the code. Go to our special URL. That way, they know that Black Box Down sent you. It's like a little way. Give them a little wink. We all know life's best moments happen around a roaring fire, and a smokeless fire pit from Solo Stove makes your outdoor moments even more memorable. Instead of having to constantly dodge campfire fumes, you can sit back, relax, and actually enjoy the fire. Sometimes it's nice to just get outside and, maybe not go too far. You stay around the home and, light a nice fire to keep things popping, as it were, outside. And Solo Stove is a great way to help you do that. If you're worried about smoky fumes ruining a good time, I got to tell you, Solo Stove is a champ when it comes to that. The smokeless design is amazing. Really cuts that down. You don't have to worry about, going back in smelling like a stack of burned up firewood. Plus, on top of that, it's super easy to light. You get it going in just a couple minutes. Can't say enough good things about that. So upgrade your backyard with a Solo Stove fire pit and create story-worthy moments without the fireside fumes. It's got stainless steel construction designed to regulate airflow, burn more efficiently. So little smoke, you wonder how there's so much fire. It's a perfect catalyst for getting outside, spending more time with family and friends, and you can build lasting memories around a Solo Stove fire pit. They're so easy to use. They're built to last, easy to light with a few bits of starter. Your fire is blazing in minutes, and they're so confident you'll love it. They offer a lifetime warranty and 30-day free return policy. Right now, you can get big discounts on all fire pits during Solo Stove's summer sale. Use promo code BlackBoxDown at solostove.com for an extra $10 off. That's solostove.com, promo code BlackBoxDown for $10 off on top of their incredible summer sale discounts.
So just to be clear, I mentioned a solenoid, as part of this signaling system. And a solenoid is like a device that converts electrical energy into mechanical work. It's like an electromagnet that's formed. You've probably seen them before. If you ever like take apart like when I was a kid, I used to take apart my like electronic toys all the time, like little cars and stuff.
Now I do it with my air conditioner.
See, that's the adult version. It's much more expensive. Like a solenoid is just like a kind of electromagnet that's formed by a coil of wire whose length is greater than its diameter, which generates a controlled magnetic field.
Okay.
You've probably seen these like in various electronics at some point, but just think of it as like it's converting electrical energy into mechanical work, like a little motor. You could think of it that way.
Okay.
So when the aircraft was certified in Brazil, the electrical system was set up in a way where the open-close solenoid of the thrust reverser selector valve was always energized. This meant that the thrust reverser actuator was pressurized to keep the shells closed, except upon landing where the command would be reversed.
So, wait, okay. It's constantly giving power saying to keep it closed.
Correct.
But then when it lands, it stops giving it power so that it opens?
Correct.
Okay, so I'm starting to see how if it's not getting enough power, and it's not.
I know it sounds bad, but I'm trying to give like a more accessible analogy, and I think I have one. So you know the brakes in your car, right? Mm-hmm. And of course, it's coincidental that it's brakes. I'm not saying this because of thrust reverser or anything.
Okay.
You know, you press the brakes in your car, and the car brakes, right?
Yeah.
It's because when you press, you're creating a pressure in the brake fluid, and the brake fluid, compresses on your calipers, and the brakes activate. Did you know in like big trucks, like in big commercial vehicles, the opposite is true?
Do they have?
The thought is, so like in your car, you need brake fluid. You press on the brakes and the brake fluid helps activate, the calipers to activate your brake. In like a commercial vehicle or in a big vehicle, the default is if there's no pressure, brake.
Oh. So
that if there's a cut in the brake lines or if the brake lines fail or if there's no brake fluid, the brakes activate and stop the vehicle.
Does that mean that whenever they're driving, they have to they don't have to constantly keep the...
No. All that happens is when in the commercial vehicle, when they push on the brakes, that relieves the pressure in the system instead of adding pressure to the system like happens in your car.
Okay. And that's just so that if something goes wrong, it automatically brakes.
Exactly.
Okay. That makes sense.
It makes sense in the commercial vehicle. So I'm just saying like these kinds of, like, I know it seems backwards here in this case, these kinds of systems do exist other places too, where you want the default to be stop. I don't know that that's necessarily the right call with a thrust reverser, but I'm just trying to like give a frame of reference where it's like these things do exist in other places.
Because I was going to say it sounds backwards, but
and the reason they did this was this ensured greater reliability for inadvertent opening of the reversers, but the way the electricity was fed through the DC bus, the reverser would not open in case the electrical bus was lost. So again, talking about kind of like the brakes, where like if the power went out, it wouldn't open.
Yeah.
So it makes it a little safer than what we initially think, right?
Yeah.
I told you, Chris, this is a very involved episode. This is a very technical
We're on
breakdown.
the journey.
So, however, that being said, there was a modification issued that changed the electrical feed to the emergency bus, and this was done to help save electrical power by de-energizing the open-close solenoid with the introduction of an open-close limit relay. And this relay energized the open-close solenoid only when there was a positive command in effect. So when the reverser is not utilized, the actuator becomes non-pressurized. So they're trying to, all this is to say, they're just trying to make sure that the logic works so that you don't end up with the reverser accidentally opening, so that there are fail-safes in place to keep that reverser from opening in case electrical power is lost or in case there's not a pressurization in the system. They're just trying to install. These are all the fail safes that they put in to make sure that the thrust reverser does not open.
Okay, yeah, because they're like, basically your initial like instinct of, that doesn't seem like a good idea. They're like, well, this is the fail safe for that.
Right. There's fail safes in place.
Yeah.
So it's like, okay, it's not so bad. And in fact, they thought it was so safe that the manufacturer has like a fault tree, like where they work through like all the different possibilities, right? To see if the thrust reverser would activate uncommanded. And before the modification, the calculated odds of this, I feel like C-3PO. The calculated odds of the thrust reverser happening were 10 to the power of 11, or 1 in 100 billion.
Oh my!
It's astronomically improbable that this would happen.
I'm curious how they calculate that. But
yeah, me too. That maybe they have a C-3PO themselves. So this is considered.
Don't ever tell me the odds.
Yeah, I was waiting for it. There it is. So of course, this is considered extremely unlikely because the odds are above 10 to the power of 9. And in the United States, there's regulations. It's the FAR 25.1309. What is that? Federal Airway Regulation? Federal Airline Regulation? I got my book right here. Hold on. It's the Federal Aviation Regulations. So according to the Federal Aviation Regulations, Chapter 25.1309 determines in brief that aircraft equipment items, systems, and installations, whether considered severally or in relation to other systems, are to be defined so that on the occurrence of any fault that might prevent the continuation of a safe flight and the landing of the aircraft, the fault is to be classified as extremely unlikely if the fault occurring should be above the order of 10 to the power of 9. So even according to like the regulations that are built, you know, they have a definition of what's considered extremely unlikely, and this exceeded that and then some. So after the modification, the manufacturer did not consider the possibility of the contacts of the secondary lock relay of the thrust reverser control system becoming stuck, and it would be a dormant failure, which means it would happen without being perceived. The diagram of the reverser's fault tree post-modification, even without taking into account a dormant failure, indicates that the probability of an inadvertent opening of the reversers is 10 to the power of 6, or 1 in 1 million, which actually does not meet the FAR airworthiness requirements. Because the manufacturer anticipated that an opening of the reverser during takeoff was extremely unlikely, they determined it was not necessary to train for such a failure. So remember, like I said, they did special electrical system modifications for the plane to be certified in Brazil, and those modifications, which is what we talked about, actually made this kind of failure more likely. So it went from a possibility of 1 in 100 billion to a possibility of 1 in a million, which still very unlikely.
More though.
Yeah, but it's way, way more likely. But still very unlikely. If it's a 1 in a million chance, you take those odds every day. Like I can't even begin to imagine what we do every day that's like, there's a 1 in a million chance this could hurt you. And you're like, yeah, it's fine.
Yeah.
So investigators carried out tests on the secondary lock actuators of the thrust reverser control system, and they found that the secondary lock of the doors of the turbine thrust reverser showed inconsistency in their responses and had a lack of reliability. They had a performance much below the minimum acceptable to assure the system's safety and reliability, and presented a share of contribution in the sequence of events that led to the non-commanded opening of the doors of the thrust reverser on the number 2 engine during the takeoff phase. So they're finding problems here, right? Even though upon investigation, the parts seem to be okay after the crash, they're like, this engineer has this hypothesis, and they're looking at it and they're like, oh, this stuff's not reliable. All of this could theoretically have happened, and seems like it did happen in this case.
Yeah.
The crazy thing to me is that what I said a little while ago, that this was considered so unlikely that they didn't train for this failure. That's never going to happen. Why even bother training it?
Well, but then you said it got the modifications they did in Brazil made it more likely, and they still right, and they still didn't train for it.
They still probably thought it was so unlikely it didn't matter, and they may not have calculated. I don't know for a fact. They may not have calculated the new odds until after this incident.
Oh.
I don't know when that new calculation occurred, but it may not have happened until after.
And it was just Brazil that they did these?
Yeah. Every country, has different standards and requirements for aircraft to be certified to fly in that country. And I don't know enough about the electrical engineering side of things to answer why Brazil had these specific requirements, but this is what they had to do to make the plane to be deemed airworthy in Brazil.
That's weird. Maybe it made other things safer.
Right, exactly. There's probably some other side effect that they were more concerned with that they wanted this done for. So based on the troubleshooting schematic manual for the aircraft, it's possible for a relay of the secondary lock to fail due to an internal fault caused by the wires to be connected to other relays. It informs that inductive loads, such as those found in the secondary lock actuator, are detrimental to the contact that commands them, particularly on de-energization, in case there is no protection diode, as is the case of the secondary lock actuator. It also assesses the possibility of existence of quick reverse cycles during maintenance services, where the reverser shells are opened and then commanded to be closed before the opening completes, might compromise the contacts in the relays. The investigators conclude that it may be possible for a simple fault to exist due to melting of electrical contacts causing the continuous command of the deploy coil and causing of the inhibition alarms. So the one thing they said there I thought was really important and really stood out to me.
Mm-hmm.
It said that it's possible that if the reversers are commanded to open and then commanded to close before they fully opened, it could compromise these relays. So like in maintenance, if someone's checking it and they're just like toggling it open, closed before, letting it fully cycle, it could degrade the system and could have caused the contacts in the relays to fail, which would have caused the reverser to open in flight like this.
My mom always used to yell at me in the car because because I fidget. You know this about me, Gus.
Oh, I know it. Yeah. I sit next to Chris all the time.
And when I was in the car and I was a kid, I was like, turn, the window up and down, up and down, up and down, or like just the lock up and down. It's like one of those things. So this is like, I thought of it. You know how whenever you press, there's a lot of the trunks now, when you press the button and it closes automatically.
Yeah, yeah.
If you push that and then pull it up or something, or like, I don't know.
Why would you do that?
I know. Or push it back up so it's not actually, I don't know.
What I was thinking
the whole mechanism
was like, auto power windows where you like push it down and then it automatically starts rolling the window all the way down. You don't have to hold it anymore. Uh-huh. It's like if you tell it to do that and then you pull up to stop it and make it start rolling up, like that kind of thing, right? But it's the same thing where it's like there's an automatic system and you interrupt it and stop it until do the opposite now.
Yeah. Oh man, anytime I'm getting out of an Uber that drives a van and they have one of those doors that shut, and he's like, no, don't touch it. I'm like, okay.
Yeah. Same thing. I don't know if you've ever been to Japan, but the taxi doors close automatically, and they get very mad if you touch the doors and try to close them. So there's signs all over them that's like, do not touch the door. Like the door opens automatically, you get out, and the door closes automatically. They get very upset if you try. Which
is understandable because it can mess it up.
Right.
Yeah.
So I mean, very very similar, right? Don't interfere with something that's automatic. Let it finish and then tell it to do the other thing. So now it's like, all right, now the investigators are trying to say, let's put all these pieces together, all this different electronic mumbo jumbo, and let's figure out how did this all come together? How did this all cause this incident to happen? So they hypothesize that during the takeoff run, remember the 2 auto-throttle channel failures occurred with their warnings? And then these warnings were canceled and the takeoff continued properly because that didn't cause a risk to the operation of the aircraft. The captain informed the auto-throttle failure probably as a warning to the first officer to adjust the levers as needed. And during the takeoff run, at the moment of liftoff, the reverser of number 2 engine opened. So the way that this system worked, there was a fail-safe. If the reverser opened in flight, what would happen is the auto-throttle would disable and the plane would automatically roll that engine back to idle.
How's that a fail-safe? So that it doesn't reverse. So that
then it's just introducing drag on that side of the plane.
Yeah.
It's not actually thrusting in reverse.
Yeah. So it keeps it from doing going the opposite direction of what you want. But
right. And remember,
they didn't realize this.
Exactly. That's exactly what was happening here. That's why the number 2 engine kept going back to idle, and the first officer kept fighting it, trying to make it go back to maximum thrust.
Oh.
And remember, the warning saying the thrust reverser was deployed didn't illuminate. The only signal of abnormality they had was the number 2 engine thrust going back to idle because there were no visual or audio warnings that went off.
Yeah. That or just the way it felt, like the plane. Could you feel that?
Well, I mean, it feels like asymmetric thrust.
Yeah.
It's probably more severe than normal because it's the thrust reverser. But, when it goes idle, it probably feels just like regular asymmetric thrust, maybe a little more drag than normal. But then, when they start introducing that power back, that's what, makes it way worse.
When all this happened, were they already past, what is it, V1?
Yeah, they were, this happened right as they left the runway.
So okay. So it's too late to not take off.
Correct. They have to take off. This happened, like I said, within 50 feet of the ground.
Yeah, so it sounds like there's no way they could have, saved this, right?
If they had left the number 2 engine idle, they could have continued. They would have been an emergency, but they could theoretically have landed it.
Okay, but they could have taken off with just one engine.
Yeah, it's not ideal. They're not supposed to. Their climb performance will be severely affected, but, they could get a slow climb and circle back to the airport.
Okay.
A plane with 2 engines can still fly with 1.
Yeah. Okay.
And I'm gonna read a little more here about their hypotheses, and then I'm gonna give a little more detail about stuff that I learned here. So the lack of prior information, instructions, and training. Remember, they didn't train for this type of abnormality. Have encouraged the impulse of the crew members to try to push that lever forward. Due to the effort in advancing the lever, the engine 1 lever was also advanced, but at this moment, the reverser cycled and caused a quick reduction of the lever, bringing the crew member's hand along, which inadvertently led to the number 1 engine also being reduced. Remember I said number 1 EPR lowered for a little bit?
Mm-hmm.
It's because they had their hands on both throttles, and then the number 2 engine rolled back as a safety, and they accidentally pulled number 1 back at the same time because they had their hands on it.
Oh, so like you say with 1 pulled back, as in it was like pulled back as in let off the thrust?
Yeah, as in like the plane as a safety, moved the throttle back to idle. And their hands were on both, so when the plane pulled it back to idle, their hand was on both throttle levers, so they pulled number 1 back too. And then they
just kind of inadvertently, because you're used to pushing, like, so you don't have asymmetrical thrust. You like are used to doing mirrored movements in the plane,
right? They should both be moved more or less together. So this is just inadvertent. The number 1 went idle because the plane was pulling number 2 to idle. So then, one of the crew members advanced both levers again, with engine 1 staying below takeoff power and the lever of engine 2 being reduced immediately again. The levers were then pushed forward again, and this time the cable that kept pulling the thrust lever back to idle was broken, allowing the thrust lever to remain forward. And this is, without any warning signals, it was humanly impossible for the crew members to identify what was going on and the loss of control that followed. So this is what I want to talk about. There was a cable attached to that it's attached to both throttles, but in this case, we're talking about the number 2 throttle that kept pulling it back. This was the safety I was talking about. It would pull the engine back to idle, and then when the levers would close, or I'm sorry, when the thrust actuator would close and be back to normal, then it would stop pulling the throttle to idle, and that's when they could push it back up to full. Then the thrust reverser would open again, and then they would, the lever kept coming back to idle. I think the amount of force that was required to break this cable, it was broken at a quick connect, was a little over 600 pounds of force. And they said it was impossible for a person to break that by themselves. But what happened was, one of the times when the reverser closed, the first officer pushed the throttles all the way to max power, and then the thrust reverser opened, and then the system started pulling on the cable at the same time that he was pushing forward, and he was fighting it. And then that's the combined forces put over 600 pounds of force on the cable, and that's what broke it.
Yeah, so it's like opposite pulls.
Yeah, it was like a tug of war, and then the rope broke.
It's all happened so fast, but when you break it down moment by moment, it's like, it's nuts.
Yeah, this all happened, remember, in less than a minute, like a minute from the time they started rolling their takeoff to the time they crashed.
God, I'm just imagining, it's like the plane's like fighting with itself.
Mm-hmm. And fighting with the crew.
Yeah.
So, overall, there was a lack of information, instructions in writing and practice, and this all contributed to the non-recognition of this abnormality. The unusual occurrence of the quick reduction of the lever on a particularly difficult phase of the operation, the non-occurrence of failure warnings, and the lack of cognizance and specific training for such an abnormality bring on surprise and distraction of the crew members' attention. So again, it's all these things lined up. Critical phase of flight, the warnings didn't go off. They didn't train for this because it was such a, considered a remote possibility. Mm-hmm. And they all got distracted.
There were no warnings. It's just.
And then the release of the restriction of the lever of engine 2 at idle without the occurrence of the abnormality warnings strengthened the tendency in at least one of the crew members to try to recover the power of the engine, because that's what you think. Your engine's idle. That's not where it should be. You try to put it back. Mm-hmm. And, it's like, you don't realize the thrust reverser's out. You're doing the exact worst thing.
Yeah, but oh my God.
And again, this all happened in like a minute or less. So there's no time to really realize that this is what's going on.
You don't have like time to troubleshoot really in that moment, at least. Mm-hmm. You just have to know, that's why the training is, you have to know, this is probably happening. Here's what I do. You don't have to be like, let's check and see because they're 50 feet off the ground.
Yeah, there's no time. And the lack of warnings and the difficulties that are characteristic of such an abnormality have diverted the crew members' concentration to thinking this was an auto-throttle failure. Remember, the auto-throttle failed on the takeoff roll. They probably thought the auto-throttle was messing up, but it had deactivated because it needed to pull the throttle back to idle to save them.
Oh, my.
The occurrence of the auto-throttle failure warnings and the lack of specific reverser opening warnings have strengthened the belief that they were experiencing an auto-throttle failure. Like, that's what anyone would think in that case. Auto-throttle's failing. It's making us crash. Fight it.
And that's what it sounds like.
Yeah, that's exactly what it sounds like.
And even whenever we're like, you talk about like, one engine's not going, so that's why they're banking. I mean, that even makes sense. But
right. It all seems like they had the right thought process, and the warning saying what it really wasn't even activating because it was also failing. Like it's incredibly frustrating because it would have been difficult, but they could have theoretically saved it if things had gone a different way. If the warning had illuminated, or if they had left the engine idle. I don't know. There are a lot of little things, but I can't fault them for any of that. They thought they were doing the right thing. The reverse fault tree chart made by the manufacturer, considering the post-modification version, even not taking into account a dormant failure, indicated the probability of an inadvertent opening of the reversers is 1 in a million, which we talked about, which, is a problem. The reverser unlocked indication system is inhibited at speeds higher than 80 knots and up to the height of 1,000 feet, exactly when the pilots would have needed this information the most. So the reverser indication system, like a warning, wouldn't have even worked below 1,000 feet.
What?
I don't know why. That's just bad. I don't.
Isn't that when you would need it the most?
Yeah, that's when you think it would be most critical.
I mean, it is when it would be, right? I mean,
yeah, when you're close to the ground, of course. The secondary lock actuators behave at a performance below the minimum acceptable to assure the safety and reliability of the system. The requirements that determine that each reverse system is to be provided with means to prevent the engine from producing power higher than idle power upon failure of the reverse system were not complied with, both in relation to the control system when the shells opened in flight, and in relation to protection, which became non-existent when the cable broke due to the pilot's action on the lever. So again, even the secondary safety of the plane automatically moving the engine to idle, that failed because the pilots were resisting it and they broke the cable. Design faults, an insufficient assessment of the fault tree diagram, and the guidance to the operator not to train for this abnormality have indirectly contributed to the sequence of events that led to place the crew facing an unprecedented situation without the possibility of recognizing and responding properly to avoid the loss of control.
Yeah, it doesn't seem like it's the pilots. It's not their fault, right?
It doesn't seem like it.
It's the Fokker's fault.
Well, either the manufacturer and or yeah, no, I know what you mean. I tried not to laugh. It definitely seems like it's either in my opinion, the manufacturer and or the Brazilian government
that made them modify it.
Correct. So,
but I feel like if they made them modify it, it should have been on the manufacturer to, I don't know, change their system so that the modification. But I guess that could be. I guess I see why it's like, oh, it's expensive if they have to redesign the plane for every country.
Right. It's tricky. Where do you draw that line? So that's why I think they both share responsibility in that regard. So during this incident, for 3 times, the thrust lever of engine 2 was reduced and advanced. Such interventions on that lever have brought on the reduction of the thrust lever of the left-hand engine, impairing the aircraft's performance. Like we said, engine 1 rolled back briefly too by accident. And then the non-return of the left-hand lever to takeoff thrust immediately has contributed to deteriorate even more to the aircraft's climbing capability. So engine number 2 was messing up. Engine number 1 went idle and then did not immediately go back to takeoff thrust. So they had less thrust than they needed. The condition under which the unusual abnormality presented itself to the crew and the lack of warning signals has rendered the intentionality of the action indeterminate, and furthermore, it was not possible to determine which of the 2 crew members has actuated the levers. So they don't know exactly who was, moving the levers. The lack of cognizance on the part of the crew members for insufficiency of warning signals and information about the abnormality has been a detriment for them to abandon the normal sequence of procedures, such as retracting the landing gear and actuating the autopilot in order to take the initiatives of prioritizing the solution of an unusual situation installed in the cockpit below safety height that eventually brought on loss of control of the aircraft, whereby it has also not been possible to determine which one of them took the initiative. Such facts render aspects indeterminate. So they're giving a little bit of blame to the crew here, saying they inadvertently rolled back number 1 engine, didn't put it back to takeoff power, and that they probably should have retracted the landing gear and engaged autopilot. Obviously retract the landing gear to reduce drag so that you get better performance out of your working engine. And if they engage the autopilot, then they could have focused their attention on troubleshooting more. I mean, yes, but I feel like there was so little time. It's difficult to say. Like everything happened so quickly. The crew tried to manage the abnormality concurrently with control of the aircraft below 400 feet. Under such risk conditions, a power reduction occurred on the other engine, compromising the aircraft's performance. As a consequence, the crew was obligated to prioritize the thrust needs to the detriment of other procedures. Based on data collected from the flight data recorder, the lever of engine 2 was brought to maximum power position after the locking of the lever at idle position. Such locking occurred immediately after liftoff when the lever was reduced by itself to the idle position, staying locked for about 3 seconds. However, the system itself released the lever, inducing the first officer to bring it to full power position, even after having informed the captain about its locking. It should be pointed out the captain has not requested such action, having been informed about the locking, as well as the first officer not asking whether such an action should be done or not. So, saying that, they kept putting engine 2 back up to full. The first officer never asked the captain if that's what should be done, even though he informed the captain about the locking. And the captain never requested it, but
also
it seems like a natural reaction.
Yeah, it seems like even if he had asked, he would have said yes. Right?
Because
that's what they were trained to do.
It's difficult to make that assumption, but it seems like most likely that is what would have happened. So there's a few recommendations as a result of this incident. Improve the quality of the analysis of all bulletins, regardless of their classification, and determine that it is mandatory for the manufacturers to remake the fault tree analysis for every and any proposition of modification in any of the systems that may in some way interfere with the aircraft's airworthiness. So this is what we're talking about. Make that fault tree. Anytime you have to make a change like this, redo the fault tree and make sure that you still have enough redundancy and that, failure is still a very remote possibility. Determine the possibility of a visual and external verification during pre- and post-flight inspections of the position of the mechanical locking systems of the secondary lock. Include a visual check in the aircraft's maintenance plan and in the external inspection prior to each flight. So just check those locks as part of the pre-flight inspection to make sure they're working properly for the thrust reversers. Modify the flight warning computer so the reverser engine warning is classified as level 3, informing the crew through the master warning. Modify the flight warning computer so that the reverser engine warning is not inhibited and is informed to the crew during any phase of flight. So try to eliminate the possibility of these alerts not reaching the crew. Eliminate the open-close limit relay, keeping the open-close side of the selector valve energized always, except when there's an actual command of the reverser. The reverser's secondary lock actuators are to be reanalyzed and have their reliability increased, including final tests of impedance and electrical resistance prior to delivery and post-assembly on the aircraft. So again, more testing, make sure that, there aren't any problems with this system. To define a primary maintenance process determining the failure modes of the secondary lock actuator, aiming to avoid the dormant failure of such components. So more maintenance, get this on a schedule to make sure it's not going to fail. Mm-hmm. To determine an analysis and tests program for the secondary lock actuator with the objective of explaining the causes of the contamination of the internal switches of such actuators, providing an effective way to avoid it. Give more emphasis to the training sessions carried out on flight simulators in relation to the opening of the reversers in several phases of flight. So again, training. In initial and revalidation training sessions, emphasize the importance of not performing actions below 400 feet. So I guess that's just like training to tell the pilots to get more altitude.
Before they do anything?
Yeah, before troubleshooting.
That makes sense. Yeah. But they were trying to get altitude by turning.
But they were still, they were still climbing. Like, think about it. If they hadn't fought that number 2 lever, they would have continued climbing and gaining altitude.
Yeah, with just the one engine.
Right. Yeah, it made it worse by trying to immediately fix it. Include in the theoretical and in the simulator training a procedure for the case of non-commanded delay of one of the thrust levers during takeoff and climbing phases. Yeah, so just, I guess better troubleshooting for what to do when, one of the levers rolls back to idle during takeoff and climbing, which again kind of ties into gain altitude and then troubleshoot.
Yeah.
But that's it, TAM 402. I think in the past we've actually had listeners ask us if thrust reversers have ever opened in flight. And I think I was very cagey about this in the past because I didn't want to potentially spoil this episode because I figured we would probably be talking about this one at some point, which seems awful to have a thrust reverser open in flight when those should only happen when you're on the ground trying to slow down and stop after you've landed.
It's terrifying. I'm just trying to imagine what that must have been like for them trying to fight it and not realizing.
Yeah, that in fighting it, they're actually making it worse.
And I'll say this is, I think, one of like 2, you talked about onlookers, eyewitness testimony and how unreliable it is. This is like one of maybe 2 or 3 other times that it was actually accurate.
Yeah, it's so wrong most of the time.
Yeah, most of the time it's completely false. And this was like, they nailed it.
And it's a good thing, I think, that they had those eyewitnesses because, remember, the initial inspection of these parts showed that they were working fine. It wasn't until they start hypothesizing and trying to see, like, what could theoretically have made this happen that they find, this fault and they find this problem. I don't know how this investigation would have gone if people hadn't seen it. I don't know if they would have dived in, and done this deep dive to try to figure out if this was a possibility.
I guess it was the eyewitnesses were also probably people who worked on planes. More new planes.
Oh, that's a good point. Yeah, I think you can take a little more, or you think someone like that would be a little more reliable in what they're saying.
Yeah, because they are at the airport taking off, and then they see this plane struggling, and
Yeah, and maybe it was even other pilots who were waiting to take off.
Oh shoot, yeah.
Yeah, I don't know. I don't know who the eyewitnesses were, but yeah, I hadn't thought about that till you said it. They were so low and right over the airport. This happened at takeoff. It very well was most likely people involved in aviation. But yeah, that's it. TAM Flight 402. Like I said, check out, follow us on social media at Black Box Down Pod. I'll post that image of the landing gear in that destroyed bedroom on top of a destroyed bed.
And that guy who's
looking at it. I don't know what he's doing. He's just like looking over the side of it.
On the right side of the bed.
It looks like he's looking for his keys. Is what I think when I see that. Like, did I leave them over here?
Were they under the wheel? Or
yeah, I don't remember this wheel being here. But yeah, that's it for this episode. We'll be back next week with another one. Don't forget to check out our link tree on the social media. Like we mentioned earlier, we have new merch that I think is great.
And we also have something new.
Yeah, we have a little supplementary episode. We wanted to do something as a thank you for everyone who subscribes to our premium or Rooster Teeth First. If you have the premium membership, we have a special Q&A episode that we posted. It's available on all podcast platforms.
We kind of we took questions from social media and email submitted questions and kind of talked through the things that people that were asking about or articles that came up, and I don't know, kind of break them down and discuss. And
yeah, we're trying to come up with a way as a thank you for everyone who supports us directly through that premium. If you're curious about that, you can check out blackboxdownpod.com. It's $2.99 a month. You get ad-free episodes. You get them early. You get this special supplementary episode, and you can keep listening whatever podcast platform you're already listening on.
And there will be more supplementary content too.
Yeah.
This is just the first.
This is the start. All right. Well, thanks for listening, everybody. We'll see you next week. Bye.
Bye.